Okay, so we have this worksheet with 8 systems of equations for you to solve. And I know you guys did all of them, but let's just double check to see if you got them right. Okay, maybe you didn't get all of them done, but I know you got most of them done. That's your story, right? Okay, let me clean this up a little bit so it's actually somewhat legible. Now, before we start on this one, how many of you actually use substitution? Or like substitution? You do? Okay. How many of you prefer the elimination method? How many are just totally freaking clueless on both of them? Okay. Well, at least you're honest.
Yep.
No matter which method we use, it helps to label the equations A, B, and C just so you don't have to read off the whole thing to refer to it. Because I think it's simpler, and because it's the way I like, we're going to do these with elimination. If any of you like absolutely hate it and want me to go back later and show you substitution, I will. Now this one is set up absolutely perfect for elimination. Can anybody tell me why?
It's all lined up.
Well, it's already lined up. X's, Y's, Z's, equals, and then the constants. But there's another reason why it's absolutely perfect.
Because Y has no attachment to it.
Perfect. Y is set up perfect. This is a positive 1, a negative 1, and a negative 1. I can pair A and B and it'll cancel out the Y, and then I can go back and compare A with C and it'll cancel out the Y. So let's do that. I'm going to add equation A plus equation B. So that means I'm adding these two right up here. So X plus X is 2X. Positive Y plus negative Y cancels out. Z plus 2Z, 3Z. 6 plus 5, 11. Okay. Now we're done with that. Now I'm going to go back and I'm going to add, that's not what I want to do. I'm going to add equation A to equation C. Because I have a positive Y and a negative Y again, it's going to cancel out one more time. So I have X and 2X make 3X. Positive Y and negative Y disappear. Positive Z and negative Z, 0. Equals 6 and negative 3 make 3. Normally at this point we would have a system of 2 equations and each would have 2 variables. But something really cool happened in this second one. The Z disappeared too. So we just got 3X equals 3. We can just go with that. Divide by 3. X equals 1. Now we can go back up to here, put in 1 where the X is. 2 times 1 plus 3Z equals 11. 2 times 1 is 2 plus 3Z equals 11. Subtract 2. 3Z equals 9. And divide by 3. Z equals 3. So X is 1 and Z is 3. We go back up here. Let's do the top one. X is 1 plus Y plus Z is 3 equals 6. Y plus 4 equals 6. Subtracting 4. Y equals 2. So the solution to this one, X is 1 when Y is 2 and Z is 3.
Go back up.
Any questions? What's that? A lot of people get confused right here when the Z disappears too and you're left with just 3X equals 3. They're like, what do you do? I need another equation. No, if 2 of the variables disappear, then you're set. Go with it. Any other questions? Well then, let's move on to number 2. 3X plus Y minus Z equals 2. x minus 2y minus 2z equals 6. 4x plus y plus 2z equals 7. Once again, I'm going to label them equations A, B, and C. This one, again, is set up very, very well for doing elimination. In fact, there are two variables that are set up well. First of all, it has x's, the y's, the z's, the equals, and the constants. That's done for us. That's always the first step. Now, the x's, not set up well. 3, 1, and 4, we'd have to go to 12. That's not going to be an easy one to get rid of. The y's are not bad. We have a positive 1, a negative 2, and a positive 1. We turn everything into 2's would be okay. The z's are also set up well. We have negative 1, negative 2, and positive 2. Well, the positive 2 and negative 2 would cancel out. We'd just have to multiply this one by 2. So we can either get rid of the y's or the z's. You guys pick. Get rid of the z's, okay? To get rid of the z's, let's start out by doing B and C. Now, why am I picking B and C first? Because I got negative 2z and positive 2z. We're good, right? X and 4x. 5x. Negative 2y and positive 1y. Negative 1y, just negative y. Negative 2z and positive 2z. Goes up. Equals 6 and 7, 13. So there is my first equation. Next, I have to use equation A now. If I use equation A, actually it's going to be 2 times equation A. I'm going to use along with equation C. Why am I doing 2 times equation A? So this becomes a negative 2z, and it'll cancel out with a positive 2z. So that's going to be 6x plus 2y minus 2z equals 4. Does everybody see where those numbers came from? 3 times 2 is 6, 1 times 2 is 2, negative 1 times 2 is negative 2, and 2 times 2 is 4.
You just double whatever
everything
the equation is in order to make it disappear?
In order to make that into a negative 2, so it'll cancel out the positive 2, yes. Now equation C, I'm going to leave the same. 4x plus y plus 2z equals 7. And let's add them. 6x and 4x. 10x. 2y and y. 3y. Negative 2z and positive 2z. Cancel out. And 4 and 7. 11. So let's bring that down here. 10x plus 3y equals 11. Between those two equations, I can get rid of either the x or the y. Let's get rid of the y. So I'm going to leave this one as it is. 10x plus 3y equals 11. I'm going to multiply this one by 3. I could multiply by negative 2. That would get rid of the x. I want to get rid of the y. If I did, I mean, I could do that. I could have multiplied by negative 2. The x would disappear, and then I would have 5y equals 30 whatever. So anyway, times 3. 3 times 5x is 15x. 3 times negative y is negative 3y. Equals 3 times 39, or 3 times 13 is 39. What the heck? Try that again. Okay. So now we're going to add 10x and 15x. 25x. 3y and negative 3y is gone. Equals 50. Divide by 25. X equals 2. Now I have to go back up to one of those equations. I'm going to pick this one. 10 times x becomes 10 times 2 plus 3y equals 11. 10 times 2 is 20 plus 3y equals 11. Then we are going to subtract 20. 3y equals negative 9. And finally, divided by 3, y equals negative 3. So we've got x is 2, y is negative 3. Go back up to one of these originals and find z. Let's do this one because that's the only one with a positive z. So 4x becomes 4 times 2 plus y becomes plus a negative 3 plus 2z equals 7. 4 times 2 is 8. 4 plus a negative 3 is 5. We shall subtract 5. 2z equals 2. And finally, divide by 2. Z equals 1. So we have x is 2, and y is negative 3, and z is 1. What you think? Ready for a sharp stick in the eye? You look like exasperated.
It's just easier to hold him down and make him do my work.
We're going to skip up to number 8 here quick. You seeing where you went wrong at all, Jared? Or?
No, I just did some math on somewhere.
Okay. When you get the wrong math answer, usually you did some wrong math, yeah. Occasionally that's the problem, at least. This one here is not set up well to do anything. So we're just going to have to pick a variable and go with it. I'm thinking y is probably my best choice. Actually, y or x. Z has got 5 and 6. I don't want to deal with 30. X or y both have 2, 3, and 4. I'm going to pick y because one of them is negative. That's the only reason why. But either x or y would be just as easy to use here. So what that means is I'm going to get rid of the y in the equations. I am going to start out with equation B. 3x plus 4y minus 5z equals 2. What should I use along with equation B? Not just C, but 2 times equation C. Very good. So now this is going to be 8x. This will be negative 4y. You see why we did the times 2 now. Negative 4z and positive 2. So we can combine 3 and 8 make 11x. 4 and negative 4 cancel out. Negative 5 and negative 4 make negative 9z. 2 plus 2 is 4. Next, we have to use equation A. We have to get rid of y. So equation A has 3y. This is a negative 2y. So I'm going to do this. I'm going to do 2 times equation A and 3 times equation C. Because 2 times 3 is 6, 3 times 2 is 6. Okay, let me go back and count that. I want to get rid of the y, so I need these to be the same number. Least common multiple of 3 and 2 is going to be 6. I multiply this one by 2 to make 6, this one by 3 to make negative 6. So A times 2 is going to be 4x plus 6y plus 12z equals 6. I just multiplied everything by 2. 3 times equation C is going to be 12x minus 6y. Minus 6z equals 3. So we add our columns. 4 and 12 make 16. 6 and negative 6? Cancel out. 12 and negative 6. 6z. And 6 and 3? 9. Now we have to use those two equations. We have 11x minus 9z equals 4, and 16x plus 6z equals 9. I am going to do this top equation times 2, this bottom equation times 3. Can anybody tell me why I would want to do that? Get rid of the z. That'll turn this into negative 18. This will be positive 18. Z will go bye-bye. So times 2 here would be 22x minus 18z equals 8. This will become 48x plus 18z equals 27. So we add 22 and 48 make 70x. The z's cancel out. 8 and 27 makes 35. We then proceed to divide by 70 to get that x equals 1/2. Now we have to go back and find, the next one we would find would probably be z, because we have the x's and z's here together. So this will be 16 times 1/2 plus 6z equals 9. So we shall do 16 times 1/2, which is 8 plus 6z equals 9. Then we will subtract 8. 6z equals 1. And we divide by 6. So z is 1/6. Now we got to find y. I'm going to go back up to that very top equation. So 2 times x becomes 2 times 1/2 plus 3y plus 6 times z becomes 6 times 1/6 equals 3. 2 times 1/2 is 1 plus 3y. 6 times 1/6 is 1 equals 3. So then we combine 1 and 1 makes 2 plus 3y equals 3, and then subtract 2, 3y equals 1, and finally divide by 3. Y equals 1/3. What do you think?
What do we do? Are the A-OK fractional form?
Yep. I tried to put them in decimal, they'd be rounded off. Well, the 1/2 would be okay, but the 1/3 would be rounded off, so it'd make it really hard to find the other values. Because when you substitute them in, you wouldn't get the exact right answer.
Wouldn't you want them in whole numbers then?
You can't. They're fractions. You can't have them in whole numbers. Sometimes the world doesn't work in whole numbers. Fractions are now our friends, remember.
Now I have a question about when we were first presented with the 3 different formulas.
Yep.
And we decided that we were going to do
Why?
whichever ones that we picked.
Yep.
Are you going to get the same answer if you went through it in a different procedure?
Yes. If I decided to eliminate x, I would still get the same answer. Yep.
If you okay, like the first one we did A and B.
Yep.
And then C and A.
Yep.
Would you end up with the same answers if you went B and A and B and C?
Yep.
So it doesn't matter. It's just what we're looking at. The reason that we're picking those particular formulas to work with each other is that's what looks like.
That looks like it's the easiest, exactly.
But you could use them in any combination.
I could use whatever I wanted to. Yep. As long as I adjust them so that they cancel out. Yeah.
All right.
It's just I'm looking at these, figuring out which one's going to be the least amount of work.
Gotcha.
So your homework, we've still got 5 more to do on there. See if you can get them done.